wondered why apples don't fly, why everything that goes up must come down, it's all down to a little thing we call gravity. An invisible force that operates like an unseen hand. It's what keeps us grounded, literally. It's the reason why we don't float off into space and why the planets are held in their orbits. Yet, as ubiquitous as it is, gravity is shrouded in mystery. Enter Sir Isaac Newton, the 17th century English mathematician and physicist. His groundbreaking work on formulating the law of universal gravitation was nothing short of revolutionary. It was Newton who first proposed that the same force that causes an apple to fall from a tree is also responsible for the moon's orbit around the Earth. But what exactly is this law, and how did Newton come to discover it? Well, stay tuned as we delve into the captivating world of gravitational force. Imagine sitting under an apple tree and having an apple fall on your head. An ordinary incident, right? Not for Newton. This famously simple moment, an apple falling from a tree, sparked a question in the mind of the young Isaac Newton. He began to wonder why the apple fell straight down. Why didn't it fall sideways or upwards? It was as if some unseen force was pulling the apple directly towards the Earth's center. This seemingly ordinary incident set Newton on a path of inquiry that would forever change our understanding of the natural world. He pondered and calculated, his curiosity never wavering. He questioned the fundamental laws of motion and the very nature of the universe itself. And from these questions, Newton formulated his theory of universal gravitation. This theory described the invisible force that pulls objects towards each other, a force he named gravity. Newton's curiosity about an ordinary apple fall would lead him to explain the workings of the universe. So, what does Newton's law of universal gravitation tell us? Well, it's quite a mouthful, isn't it? But don't worry, we'll break it down together. At its core, this law states that every particle of matter in the universe is attracted to every other particle. Yes, you heard it right, every single particle. And this attraction isn't some vague, whimsical thing. It's a force, a pull, that's directly proportional to the product of their masses. That means the bigger the particles, the stronger the pull. But there's a catch. This force is inversely proportional to the square of the distance between their centers. So as the distance increases, the gravitational pull decreases, and it does so quite rapidly. It's like being at a concert. The further away you are from the stage, the quieter the music gets, and it gets quieter much faster than you'd expect. Now, this isn't just some earthly phenomenon, it's universal. It applies everywhere in the universe, from the smallest pebble on a beach to the largest star in the cosmos. They're all playing this gravitational tug-of-war. This law, as complex as it may sound, is actually quite simple when you think about it. It's all about attraction and distance, and it's this simplicity that makes it so profound. It's the reason why planets, including our own, orbit the sun. They're caught in this constant game of cosmic tag, being pulled by the sun's gravity but always staying just out of reach. It's why the moon orbits the Earth, forever circling us, caught in our gravitational embrace. And it's why we aren't floating off into space right now. The Earth's gravity keeps us firmly grounded. So, in a nutshell, Newton's law of universal gravitation is the invisible string that connects everything in the universe. It's the silent symphony that orchestrates the cosmic dance of celestial bodies. This simple yet profound law explains why planets orbit the sun, why the moon orbits the Earth, and why we aren't floating off into space right now. The impact of Newton's law of universal gravitation can't be overstated. This law, formulated by Sir Isaac Newton in the 17th century, has forever changed our understanding of the cosmos. It was as if a veil had been lifted, revealing a universe governed by predictable, mathematical laws. This was a game changer for science. By understanding gravity, we could predict the motion of celestial bodies, leading to advancements in astronomy and space exploration. We could send spacecraft to the moon, Mars, and even beyond our solar system, all thanks to Newton's groundbreaking work. This law stands as one of the greatest achievements in the history of science, a testament to human curiosity and intellect. It's not just about apples falling from trees, it's about the invisible threads that bind us all, from the smallest speck of dust to the largest star, in a cosmic dance of attraction. So the next time you see an apple fall from a tree, remember the law that connects us all to the stars and beyond.